It was a revelation that stunned the world. Voyager 2, humanity's oldest active deep space probe, had fallen silent. Without warning, it vanished into the vast, uncharted reaches of interstellar space, billions of miles from Earth. For nearly 2 weeks, NASA scrambled to detect any trace of life from a 46-year-old spacecraft. Then, on an otherwise uneventful day in August 2023, something extraordinary happened. A faint transmission, barely a whisper, echoed from the distant edge of the cosmos. What NASA uncovered next would not only astonish the global scientific community, but also redefine the narrative of space exploration. From 13 billion miles away, in the unending darkness, a lonely traveler stirred. For over 4.5 decades, Voyager 2 had continued its silent odyssey. Built with decades-old technology, older than most of the current population, it carried with it a golden record. A time capsule of Earth's sounds, music, and greetings in over 50 languages. A symbolic message in a bottle, cast into the cosmic sea. In July 2023, that bottle went dark. For 14 harrowing days, this venerable spacecraft, the most distant and longest operating emissary ever created by humans, vanished from the grid. NASA engineers watched in disbelief as Voyager 2's steady data stream, uninterrupted since 1977, suddenly ceased. No backup probes existed nearby. No repair missions could be launched. There was no physical way to intervene. Voyager 2 was lost to a realm untouched by human presence or voice. And then a miracle from the depths of space. A tiny pulse returned. Faint, nearly swallowed by cosmic noise, but unmistakable. Voyager 2 was alive. Like a heartbeat in the void, the signal reached Earth. Humanity exhaled. The world watched as NASA prepared to attempt its boldest long-distance rescue ever. This wasn't just about salvaging an old machine. It was about preserving a voice, a symbol of our presence among the stars. A relic from the golden age of space exploration, still carrying our hopes. To truly understand why Voyager 2's silence captured global attention, we must revisit the summer of 1977, the era of disco, the debut of Star Wars, and a rare planetary alignment, one that occurs only once every 175 years. Scientists dubbed it the Grand Tour, a unique chance for a single spacecraft to visit Jupiter, Saturn, Uranus, and Neptune in one mission. Voyager 2 launched from Cape Canaveral on August 20th, 1977. Its twin, Voyager 1, followed 2 weeks later. Originally, the mission was slated to last just 4 years. No one imagined these spacecraft would survive nearly 5 decades, or become the first human-made objects to exit the solar system. About the size of a compact car, each Voyager carried a computer with just 69 kilobytes of memory, far less than the simplest modern calculator. Yet these small, humble machines achieved one of the greatest scientific feats in history. Voyager 2 is still the only spacecraft to have visited all 4 outer planets. It revealed volcanic eruptions on Jupiter's moon Io, captured the stunning complexity of Saturn's rings, and made humanity's first direct contact with Uranus and Neptune. Then came July 21st, 2023. After 46 years of steady operation, something went wrong. At NASA's Jet Propulsion Laboratory in California, engineers had sent what should have been a routine command. Routine commands were sent to Voyager 2, standard alignment adjustments and system checks that had been executed thousands of times before. But this time, something went wrong. The spacecraft high-gain antenna, its vital communication lifeline, shifted just 2 degrees off target. That angle might seem negligible, about the width of a thumb held at arm's length. Yet across the vast 13 billion miles of interstellar space, it spelled catastrophe. Imagine trying to aim a laser pointer from Earth at a coin on the moon. That's the precision required. The signal disappeared instantly. Voyager 2 went silent. The NASA team faced a sobering truth. No nearby satellites could assist. There were no cameras on board to offer visuals. No astronauts could be dispatched. No tools could be deployed. Voyager 2 now drifted alone and mute, in a realm where our sun is just one faint star among billions. Suzanne Dodd, Voyager's project manager, confessed to a terrifying fear that contact might never be restored. The implications were profound. Nearly 50 years of engineering brilliance and human ambition now potentially lost in the cold silence of deep space. The loss came at a particularly cruel moment. Voyager 2 had been transmitting invaluable data, unprecedented readings of cosmic radiation, plasma, and magnetic fields from uncharted interstellar regions. Each signal carried knowledge we may never gather again, not for centuries, if ever. And now, that stream of discovery was cut off. For nearly 2 weeks, 11 long, silent days, NASA's Deep Space Network sprang into action. Massive radio antennae spread across California, Spain, and Australia searched the sky relentlessly. Some as large as stadiums. These immense dishes are Earth's ears turned toward the stars. Engineers worked around the clock, scanning frequencies, fine-tuning instruments, hoping for even the faintest echo from Voyager 2. But the silence was crushing. By 2023, Voyager 2's transmission power had dwindled to just 23 watts, barely more than a refrigerator bulb. That weak signal had to journey nearly 13 billion miles. By the time it reached Earth, it was billions of times weaker than the signal from a watch battery. Detecting it was like trying to hear a whisper in New York while standing in Los Angeles. And now, with the antenna misaligned, that whisper had become almost undetectable. As the days dragged on, dread grew. Every morning, without a signal, raised grim possibilities. Had radiation finally damaged critical systems? Had power reserves dropped below sustainable levels? Had Voyager 2, after nearly half a century, reached its quiet end? For NASA, and for millions around the world, this wasn't just about losing a machine. It felt like the fading of a dream, a symbol of humanity's insatiable curiosity, of our drive to explore the unknown, was slipping away. Meanwhile, strange behavior had already begun surfacing from its twin, Voyager 1. Back in late 2017, engineers noticed something unusual in the telemetry. Voyager 1's ACS, the system responsible for keeping its antenna aimed precisely at Earth, was reporting orientations that should have broken contact entirely. Yet the signal remained clear and steady. It was like getting a phone call from someone who claimed to be at the South Pole, while your caller ID showed they were next door. Initially, the anomaly was blamed on aging hardware. After all, Voyager 1 was built with 1970s tech and had braved over 4 decades in the harshest environment known to man. Glitches were inevitable. Engineers initiated self-diagnostics. Still, the issue persisted. Months of analysis led to a baffling conclusion. Voyager 1 appeared to be pointing in 2 directions at once. Clear signals, impossible readings. Voyager 2's communication link remained stable, but its internal systems began reporting data that defied logic. Then, in 2023, the mystery deepened. The spacecraft's plasma wave sensor started detecting regular, repeating waveforms unlike anything previously recorded. These weren't random energy spikes. They followed precise mathematical patterns and exhibited specific frequency relationships. The signals would appear for several hours, disappear, and then return with subtle variations. It was as though Voyager was passing through structured, organized regions of space, regions that didn't align with any known astrophysical models. Some scientists proposed that the signals resembled standing waves in the interstellar medium, akin to the harmonics of a vibrating guitar string. Others speculated that Voyager might be brushing against the invisible threads of the cosmic web, the vast, filamentary scaffolding that binds galaxies together. Yet, no existing theory could fully account for the consistency or precision of the signals. Could this be the first faint indication of something beyond our understanding? Perhaps even an intelligent presence acknowledging the spacecraft? Heat from the void. Then, in early 2024, Voyager 1 added another layer to the mystery. Dormant thermal sensors, tools once used during planetary flybys but inactive for decades, suddenly began registering anomalous temperature changes. These instruments, designed to function in the near absolute zero vacuum of space, started recording rhythmic thermal pulses. Every 4.8 to 8 hours, the temperature spiked by nearly 30 degrees Fahrenheit before gradually returning to baseline. This cycle repeated with uncanny precision, too regular to be random and too synchronized to be internal. Even more astonishing, these heat pulses were perfectly aligned with the electromagnetic patterns recorded months earlier. Whatever was affecting one part of the spacecraft was interacted with others as well. NASA ran exhaustive diagnostics. Could residual heat from the onboard radioisotope thermoelectric generator be responsible? Could electrical interference or circuit anomalies be the cause? One by one, all internal possibilities were ruled out. The only viable explanation: Voyager was encountering a precisely timed external energy source. And the strangeness didn't stop there. Despite these stressors, Voyager's power systems began performing better. Power regulation became more efficient, something its old programming was never designed to handle. It was as if some unknown force was not only disrupting the probe, but also somehow enhancing it. Like watching a dying, overheating engine suddenly improve its mileage while breaking down. Two opposing effects happening in tandem, pointing to a force beyond the spacecraft's own design. A final countdown. Yet, even as the phenomenon unfolded, Voyager 2's slow decline continued. Its nuclear power source, a radioisotope thermoelectric generator fueled by decaying plutonium, loses about 4 watts per year. That may sound minor, but when the entire system runs on the energy equivalent of a few dim light bulbs, every watt counts. Hard choices have followed. In October 2024, NASA shut down the Plasma Science instrument, which once measured solar winds and interstellar particles. Then, in March 2025, the low-energy particle detector was powered down, a device that had been recording cosmic ray data since the Carter administration. Now, only 3 instruments remain: the magnetometer, the plasma wave antenna, and the cosmic ray telescope. These will likely continue collecting data into the early 2030s. If everything holds together perfectly, eventually, the generator will no longer produce enough power. The transmitter will go silent. The computer will shut down. For the first time since August 20th, 1977, Earth will lose contact with its most distant explorer. Repairs across the void. What may be the most awe-inspiring aspect of Voyager 2's journey is that every fix, every update, every miraculous recovery has been carried out remotely from nearly 13 billion miles away. Each command takes about 20 hours to reach the spacecraft. There is no real-time feedback, no second chances. Every instruction is a gamble, a whisper cast into the cosmic dark. And yet, for nearly 50 years, it has worked.